Hey guys, welcome back to my channel. In today's video, we're going to look into exactly what would happen if all the black holes in the universe collided. For as long as I've been able to engage with scientific experiments, documents, blogs, videos, and articles among other things, I've always loved sharing all the knowledge I've acquired with a large number of people. Before we begin, do you have any idea what black holes are and how they came to exist in the universe? Let me know in the comments section below. The universe as we know it has existed for nearly 14 billion years, which is pretty much enough time for the gravitational force to pull together matter in the solar system into clumps, clusters, and collapsed objects. As of right now, the universe is filled with galaxies, stars, planets, and even large structures that are all bound together against the backdrop of the continually expanding universe. Inasmuch as things aren't always as clean and neat as they sound, some of the systems that are continually forming tend to have a great number of objects in them, and collisions are bound to occur between them over time. Whenever any collision occurs, everything in the universe tends to change, either negatively or positively. That said, we would need to understand what a black hole is, their sizes, and their formation before explaining the cosmic events that would occur if all the black holes in the universe collided. So what exactly is a black hole? Well, according to NASA scientists, a black hole is described as a place in space where a gravitational force pulls so much in such a way that light cannot get out of it at all. These black holes are so dense to an extent that they begin to create deep gravity sinks. More often than not, the gravity is quite strong because a great deal of matter has been compressed into a very small space. This mostly happens when a star is dying. Because no light is able to find its way out, we begin to see black holes. Generally, black holes are invisible, but space telescopes that have special tools to use when viewing the solar system are used to identify these black holes. All in all, these special tools have the potential to see how the stars that are much closer to the black holes behave differently from other ordinary stars in the sky. How big are these black holes? Usually, black holes are either big or small depending on the situation. As established by NASA scientists, the smallest black holes are as small as a single atom. These particular ones are very small, but they have the mass close to a large mountain. Another type of black hole that exists are the stellar. For these specific kinds of black holes, its mass has the potential to be up to 20 times more than the overall mass of the Sun. There are so many in number and exist freely in the Earth's galaxy. Just for the record, the Earth's galaxy is identified as the Milky Way. Aside from the two we have mentioned, the largest black holes that have been identified by scientists are known as supermassive. Now, these ones have masses that are much heavier than 1,000,000 suns put together in one piece. It has been confirmed that every single large galaxy contains a supermassive black hole towards its center. The supermassive black hole that is at the center of the Milky Way is known as a Sagittarius A. It's further established that the Sagittarius A has the ability to fit inside a very large ball that can accommodate a few million Earths. How are these black holes formed? There is the continuous notion by most scientists that the tiniest black holes were formed at the time that the universe began. Stellar black holes, on the other hand, are made when the center of a huge star collapses or falls in upon itself. When this happens, it immediately results in a supernova. A supernova is the name given to the cataclysmic explosion of a huge star at the end of its life. Supermassive black holes are said to have been made at the same time at which the galaxy they are in were formed. I bet that at this point, you may be wondering how scientists are able to know that black holes exist, considering that they are black and in space. Well, a black hole cannot really be seen because of the strong gravitational force that pulls all of the light towards the center of the black hole. Inasmuch so, scientists are able to see how strong the gravity affects the gas and stars surrounding the black holes. What scientists do is that they take their time to study the stars in the sky to find out whether they are flying around or if they are orbiting a black hole. On top of that, when a black hole and a star are close to each other, very high-energy light is created. This kind of light isn't the type that can be seen by human eyes. For this reason, scientists use telescopes and satellites in space to identify and view the high-energy light. Do black holes have the potential to destroy Earth? There's no point in time where black holes go around in space eating up planets, moons, and stars. So, Earth may not really fall into a black hole because there's no black hole that is close enough to the solar system for that to happen. Also, even though any black hole that has the same mass as the Sun were to replace the Sun and take its position, the Earth would remain intact and not fall in. The black hole would therefore have the same gravitational pull as the Sun itself. What would happen is that the Earth and all the other planets would orbit the black hole the same way they currently orbit the Sun. Just to clear it up, the Sun may never actually turn into a black hole, as it is not a big enough star to make one. So, what happens if all the black holes in the universe collided? When you merge a black hole with another black hole, you're likely to get an even more massive black hole than the ones that originally existed at first. However, there's a catch. You may end up losing approximately 5% of the original mass of both black holes. Well, has this ever happened before? Yes. The first ever black hole collision that we've seen in history was one of a 29 solar mass black hole merging with a 36 solar mass black hole. When these two collided, rather merged, they were able to create a massive black hole when final mass was at 62 solar masses. If you look closely at the end result of this collision, we can establish that a total of 3 suns worth of mass was lost in the process. I guess you're probably wondering where all the 3 suns worth of mass may have gone. Well, it was definitely emitted in the form of gravitational radiation. That is, the gravitational waves that LIGO has detected from over 1 billion years ago. For a brief moment, let's say one that lasts a lot less than 2 seconds, 2 black holes that collide have the potential to emit a lot more energy into the universe than all the stars combined. The X-ray emission comes from the hot gas surrounding and merging black holes. In the process, jets of particles are launched at speeds similar to the speed of light. As mentioned earlier, the gravitational waves sent out when 2 black holes ultimately collide can be detected through the use of very sensitive instruments on Earth, as they are quite invisible. Hey, that's it for today, guys. I hope that you've been able to enjoy learning all the important things about black holes that exist in the universe. Keep exploring more on hypothetical questions about cataclysmic events by subscribing to our channel and keeping up with my science videos. Also, don't forget to like this video and share it with your friends and family.